Hello everyone. Today I am going to introduce you a cutting edge tool used for protein structure prediction, that is TRO setup. So to access this tool TRO setup, simply search for it in your browser and click on this link. This is the first link that appears. Okay, so this link will direct you to the official TRO setup website. So this is the homepage of TRO setup. So TRO setup stands for Transform Restrain Rosetta. It's a fast and accurate algorithm that helps predict the 3D structure of proteins. So protein structure prediction, we all know it involves determining how the amino acids in a protein are arranged in space, which is crucial for understanding its function. So TIA-Rosetta stands out because it combines two powerful approaches. First, it uses deep learning to predict how different parts of a protein are positioned relative to each other, and then it applies Rosetta. This is a well-known modeling framework to fine-tune the structure using energy minimization. So what's even better is that TIA-Rosetta doesn't just work from scratch. It can incorporate known structures of similar proteins or homologous templates to make its predictions even more accurate. This means it's flexible and effective whether you are working with well-studied proteins or entirely new ones. Okay, so its performance is truly impressive. TIA-Rosetta has outperformed other methods in global competitions like Cas13 and Cameo. CAS, CAS stands for Critical Assessment of Protein Structure Prediction. So it is a global competition held every 2 years to evaluate the performance of protein structure prediction methods. And CAS13 was the 13th edition of this competition. So researchers are given amino acid sequences of proteins whose structures are unknown to test their algorithm. And the results are compared to experimentally determined structures to access accuracy. So CASP is considered a gold standard for benchmarking protein prediction methods. And then Cameo, it stands for Continuous Automated Model Evaluation. So this is an online platform that continuously tests the accuracy of structure prediction tools. So predictors submit models for newly released protein structures in Protein Data Bank or PDB. Then the predicted models are compared to the experimentally determined structures to measure accuracy. So unlike CASP, Cameo operates continuously and provides real-time evaluation. So both CASP and Cameo are key benchmarks to validate the reliability and precision of tools like TR Rosetta. Okay, back to our topic, TR Rosetta. This is the homepage. So here is an introduction section here which briefly explain about the tool. So this is a groundbreaking tool. We already told that builds protein structures using deep learning predictions of inter-residue distances and orientation. It then uses Rosetta energy minimization to refine the model, and the major results where it generates five highly accurate 3D structure models with estimated global and local accuracies. Then it predicts inter-residue contacts, distances, and orientations. And it also provides the top PDB templates when homologous structures are available. Okay, so this is the submission portal where you can input the data for protein structure prediction. You can paste the protein sequence into this text box, or you can upload a file containing either the protein sequence or a multiple sequence alignment here. Okay, then if you are using a single protein sequence, select this query sequence option as input type. Or if you are using a multiple sequence alignment for the protein of your interest, select this query MSA as the input type. So up to this is mandatory. Then here you can provide an email address to get the results directly to your inbox, and you can also assign a name to the target protein for easy reference. So these are optional. Then there are some other options in this checkbox, like first is do not use template. So selecting this will disable the use of PDB templates. This is useful if you want the prediction to be based solely on your sequence data. Then run TROSTA X single. This mode is for single sequence folding, which is ideal when no homologous sequences or templates are available. And keep my results private. This ensures your data is confidential. You will receive an unique key to access the results. Okay, so actually TR-Rosetta is a hybrid protein structure prediction tool that uses three methods: threading, homology modeling, and ab initio modeling. Threading means it matches the query sequence to non-protein structures in a database, even when the sequence similarity is low. So it works by recognizing conserved folds, providing a rough framework for modeling. And in TR-Rosetta, this happens in this step 2, where the tool checks for structural templates. It's useful when evolutionary relationships exist, but aren't obvious from the sequence. Then homology modeling. It is used when the sequence has high similarity to a non-proteins. TR-Rosetta aligns the sequence to a closely related structure and refines it for better accuracy. This also happened in the second step. Okay, and it's a most reliable approach when good templates are available. Then if no templates are found, TR-Rosetta switches to ab initio modeling. It predicts the structure from scratch using deep learning, which analyzes residue distances and orientation. And this method is used in later steps when there is no structural information to guide our model. So TR-Rosetta first tries threading or homology modeling for template-based predictions. If no templates are suitable, it uses ab initio modeling to predict the structure entirely based on the sequence. So it combines the strengths of all three approaches: threading for conserved faults, homology modeling for high similarity sequences, and ab initio modeling for novel proteins. And this make it a powerful and flexible tool for protein structure prediction. Okay. Uh, then once you have filled in all the fields, we have the submit option to start the prediction, or reset option to clear the input fields.